I think LSAS was one they did. And then when someone connected, you impersonate that person. And it would be the system user a lot of times, right? That was a major fix to when it is SE impersonate privilege. Generally, because when you have that privilege, you can compromise a machine, no problem. But I can do that same attack I just did, but I would impersonate administrator. Even if that failed because of my packet parsing in that sense, I would still acquire their token. So it's pretty nasty. Now, on Vista Enterprise, in this example, those are the accounts that have that privilege. Okay? ASP.NET, local service, network service. What you'll notice is those are accounts that are on the outside of all the server applications. They were given these permissions that were lower for a reason. So you can get local system when someone exploited an IS system, right? Or MSSQL, they're all given these privileges. But they have the SE impersonate. So if you compromise one of these processes, you can impersonate RPC control or something else that's there, and then impersonate that way. And that goes against the model they currently have, so I don't know how that would be fixed. Here I kind of mentioned that a little bit more. You also have the SE create global privilege. That makes it easier too, so you can create shared memory and other objects that are restricted when you have these lower accounts. So it's interesting to think about those are the kind of the two checks that are in place that prevent you from escalating easily. But because they've been there for so long, all the software relies on them. So once you realize you have them and use them, it becomes more dangerous. Yeah, and today kind of in NT land, the general assumption is if you can get SE impersonate privilege, you can become system. There's just so many avenues that have not been fixed or cannot be remediated. They're just done from access control. But once you have that, you get one of those accounts. Another interesting kind of tidbit here. So Mutex objects, when those are created, it doesn't matter if there's an object already there with that name. They'll just use that. So you can create a bunch, and then they'll come and just use yours for mutexes. Which, it's not a whole lot you can really do. You have events and some stuff that happen. You can trigger maybe application will check to see if an application is listening before it accesses shared memory or calls RPC, so you can signal that and cause it to do certain things. Or you can keep a firewall from loading, but all that's trivial stuff. So protecting yourself, so you want to tighten the DACL at creation, set a default DACL for the process. Create a library or utilitarian class or something people can use with your software or software of companies you work with that will restrict these. Solved. You have to go through and spot fix all these things in the code. You just do it one place, and in the back end, it'll use that by default. When it inherits, it'll inherit from your secure object. You need to assess DACLs and a previously owned software configuration. Things like file systems you can use the tools to search for. Giant SMB file systems for corporations I've seen are a mess. But you can use something like that to just run overnight and find all the problems. Find out corporate projections that are open to everyone, that kind of thing. Let's see. All right. The last thing is private namespaces are really interesting. So I think this is Microsoft's solution to solve a lot of the problems that I've mentioned, and probably maybe not some of them, but maybe more of them. Who knows? It's a very interesting concept. Unfortunately, it's only in Vista and Windows Server 2008. That's the one problem. But the way this works is you create think of it like a barrier. It's basically a private prefix. Say I create secure or company name, whatever it is, right? Company. And I give that a boundary description where I attach certain people to it, certain accounts in the system. They can access this new prefix. You have local and global. You have one called Acme Company / the object name. From that point on, only the people in that group can access that. It allows you to create your own custom prefixes. And they're also hidden from the object manager, so you can't see them. Only way to see these things is to get into the kernel and put breakpoints in the table access and look in there. So that's kind of interesting. The problem is it's only in Vista for now, so for software vendors, obviously, they need to support XP, and that kind of change is somewhat problematic. Some tools. Application Verifier is a tool, a Microsoft development tool you can use to validate a lot of code that you're working on for, memory leaks, handle leaks, all sorts of cool stuff. There's also things in there for object squatting. For example, if you're creating objects in a way that are, in global namespace, that kind of thing, they'll warn you about them. To a degree. Not really how helpful it is, but it's informational. WinObj is a tool that I just used to kind of peer around and look at things. Access check I'd mentioned. And then ObjectTrace is a tool that I wrote, actually, to help solve some of these problems. So it allows the tester to monitor creation of all system objects and local objects susceptible to squatting or compromise. implemented via the Object Manager callback in Vista. There's a new callback implemented in SP1 that you can hook in and monitor certain events in the NT kernel. The problem is you can only look at processes and threads. It's made for antivirus vendors and whatnot. But there's just a flag. If you look at the routine and the kernel that creates this, it's just a flag. So I don't know what it is at the document. It's just 40. And you go and you flip that in the type. Now you can monitor all the objects. So they haven't enabled that publicly, obviously. It gives you can create a pretty powerful tool using those. So hopefully this works. Good grief. All right. Let's switch over here. Okay. I'll switch back over to my administrator mode. You guys have any questions so far at all? I've kind of skimmed through pretty fast. Yeah?
How do private namespaces stop name squatting? Why don't you just name squat the private namespace?
Because you can't enter that namespace unless you're one of those SIDs.
Yeah, but why don't you just create the namespace before the other people try to create the namespace? And when you
See,
go into the namespace, how do you know the namespace wasn't created by somebody?
that's actually a good point. If you created one with,
I don't understand.
if you created one with the same name previously, that'd be, I don't know. I think they're also tied to the boundary descriptors as well, though. Those are attached to the private namespace. So I think you have to have a matching boundary descriptor, if I remember. Yeah. Nice try, though. I actually worked with this guy. He was trying to shoot me down.
I'm not trying to shoot you down. I'm just saying that it's moving the problem.
No, I think you're right. It's worth looking into. Okay, let's get back to this. All right. So ObjectTrace. God, I hate UAC more than anything in the world. All right. So let's run this. So it goes and gathers objects that are being created live by applications. So it's probably more useful for finding security holes right now than it is for testing your software. But what it allows you to do is you can pick one of these objects. Say we have files here, keys, sections, anything. And I go into the kernel and do a backtrace. So you can see exactly where these objects are created. So at the least it's neat because you can see exactly where an RPC endpoint is created in the system. You have to dig around through DLLs all day and night and try to figure out where it is. Right? It'll grab exactly where it is. Dress it up with symbols for all the objects as well. And you also have security privileges for all of them. I list all the object privileges associated with the object that are here. I don't stick to the read, write, in the controls. I show all of them because there's things like key all access, create link, subkey, enumeration. These aren't a lot of more you can't set, right? Some of them are even undocumented. So it's kind of interesting. You can see some permissions that may allow you to do more than you think they would that are there, right? But you just don't see that edit security tab that's been used for the last, 10 years. What else? So we can also have a concept of filters here. So I create a filter for, say, object type equal to any account, and I'll pick, let's pick everyone. Has any privilege. And I can highlight, exclude, or include. I'll say I only want to include them. Add a rule, apply it. Now I only have objects that have everyone privilege on the whole system. It's kind of like doing an access check across all the undocumented functionality in NT, right? So for example, this is interesting. Some of these root objects, like the root hard drive, the root drive directory, and these have access to everyone. And that's, of course, as everyone, you can go in the root directory and create a folder called test. It's kind of strange. But you have privileges like that people don't really know about. I can create a software directory and, for example, / program, application company name, and put my stuff in there. And then when they overwrite, it'll fail and maybe create symbolic links. I don't know. It's kind of strange. It's just that way. So, and you have search functionality. You can search and hit highlighting all that stuff. This is available on iSec's website if you guys want to check it out sometime. That's on the slide deck here, actually. Yep. iSec partners, tools. So conclusion. So we often make assumptions about these systems, and one of the reasons I started this project is everyone telling me there's no problems in this, it's been hard, it's been used for so long, and I like to go after those kind of projects because those are the ones that if you spend enough time on, you find strange nuances and issues and problems, and there are some there in this case. Most applications create objects in a way that's not secure. So It's kind of interesting to think about the escalation possibility.